Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our Marine Auxiliary book. This is the chapter number 5, and today we are going to talk about the power steering systems. And yes, we are going to explain the mechanical steering systems and the hydraulic steering systems. And for the mechanical steering systems, we are going to analyze the typical steering systems are rotary systems with cable systems, and the rack and pinion systems, both of them commonly used in small boats, and the hydraulic system, the hydraulic power steering system. We are going to check the system, the pump, the lines, the reservoir, how the reservoir should be installed, and the actuators, the different type of actuators, the advantage of actuators with a single shaft and the actuators with double shaft, and we are going to analyze the power assisted unit. The power assisted unit that we analyze in our book of electronics in the chapter related with the autopilot. We are going to use the same explanation of that book in order to refresh the concept of the power assisted unit. In this particular case, for marine application, the power assisted unit is electrical and is activated as soon as you start the autopilot system, or if you prefer, with a separate switch in order to improve the performance of the steering system. It's a soft system when the power assisted unit is running. Yes, we are going to check those concepts, and we are going to verify how important are the steering systems in our boats, the different type of those systems, the service, the procedure to replace the cables, the quality of the cables, and a couple of systems electronics. Now we are going to check an stand that I prepared for you with the three most common systems. I prepare the rack and pinion systems, the rotary cable, and the single unit with the pump on the helm, and the lines, and the actuator for a typical outboard boat. And after that, we are going to analyze the hydraulic system for power steering systems, how those systems work, how the reservoir is integrated in the system, and how the power assisted unit can be integrated in order to improve the performance of the system. And yes, I am going to visit different scenarios in order to explain better each situation. We are going to check right now the three most common type of steering systems. I have in this example the three types of a steering system. The most common mechanical system, the first one is the rack and pinion. This is the rack, exactly like the rack that we have on the screen right now. This is the rack and this is the pinion. And with the pinion is moving on the rack, the end move the rudder. That's the rack and pinion. What is the inconvenience with the rack and pinion? The lubrication, grease. Always should be properly lubricated. Other inconvenience is the length of the rack. For that reason, this system is not used in center consoles, because the majority of the center consoles, the console is smaller. No room for that element. Those rack and pinion were used some years ago in inboard gas boats with two engines, two Crusaders, two Mercruisers. The rack and pinion is a mechanical system, it's reliable, it's strong, but it's not used today. Every day is less common, the rack and pinion. Other mechanical system is the rotary system. In the back, we have the rotary element that we have on the screen. And this element is a mechanical system, and this is the end. The end is going out, and the end is going in. And in the back, we have the movement of the cable. The cable is going out and the cable is going in. Annie, this is the cable for a new rotary system.
Yep. This is the rotary. Remember, it has the planetary gears, the ring gear,
like the video,
right? So when you turn the wheel, the gears grab onto here,
enter over there, yeah,
and moves this cable. Look how it moves.
And
this steers the motor, the outboard motor.
Correct.
Stern drive motor, same thing applies.
Yeah,
now, if it's a rack and pinion, it'll look a little different.
It's easy to replace, no?
It's easy to replace.
Easy to replace. All right, nice. And the secret, the lubrication.
Lubrication.
No? It's a special grease, lithium grease.
Yep. And if you notice, it has a little space here because when you put it in there, there's a clip that goes in there that holds it. If not, it won't hold it. Then it'll move.
That's for the rotary system.
Yeah, and you have to pay attention on which side you put it on.
Oh,
if you're on the wrong side, then you return the opposite way.
Correct.
So anytime you change a cable, you always have to turn the steering wheel to make sure.
If you enter for this side or for the other one.
Correct.
That's very important. That's the secret. Yep. And be careful putting back the pin, no?
Yes, and you cannot do sharp bends with this. It's not very flexible.
No.
You bend the cable hard.
And after that, you have a problem when you pass over there.
There'll be stiffness.
Yeah.
Because it's rubbing against the cable inside.
Correct. Okay. And this is the rotation of the cable. This is the rotation of the cable. We have the two most common mechanical system, rotary system, and we have the rack and pinion system. The other system is the perfect hydraulic system. We have the pump, we have the wheel, and it's a hydraulic system. We have the lines, and the lines communicate in the back, port side and starboard side. Port side and starboard side. This one is used for the return. When the system have connected the reservoir tank, this element is connected with the return. And in this moment, this is connected with the port side, and the other one is connected with the starboard side. And those are the bleeder in order to bleed the systems. Those are the bleeders to bleed the system. Here on the pump, on the hand, is where you added the fluid, and also you can bleed the system over there. Okay, my friends, and now we are going to analyze the hydraulic power steering system. We are going to refresh that concept that we analyzed in our course of electronics. We are going to refresh part of that video where I explain in details the hydraulic power steering systems and how the power assisted unit can be integrated on the system. Right now we are going to talk about the power steering system, the power assisted units, how they work integrated with the autopilot, and how is the troubleshoot with that units. The first one is the helm. The second one is the cylinders. And the third one are the lines, the pipes, the connections in between the helm and the cylinder at the end. This is a typical hydraulic steering system. And we are going to check right now the components of that system. All right, in the picture you have the basic hydraulic system for in this particular case for a dinghy boat. If you check in this picture, we have the helm. This is the helm located here, and the pump is located over there. Those are the lines, and here we have the cylinder. That's the cylinder. This is a special cylinder. This is a cylinder double action, double force. This is a cylinder double action, and double force. This is the cylinder normally used in a steering system, in power steering system. We are going to talk in the book of hydraulic system in details about those cylinders and the difference between this one, double action, double force, or single double or double single. Depends. Depends, and we are going to study those cylinders in that book, in the hydraulic book, in the auxiliary book. All right, we have the cylinder, we have the lines, we have the helm or pump. On the helm is located the pump. Right now we are going to talk about the pump. All right, this is the most simple system. This pump is moved by the wheel. When the wheel is moving, this pump produce maximum 60 psi, maximum, but normally is around 35 psi. 35 psi. This is the pressure of this manual pump. This is the pump. This is the pump. The pump is located here on the helm. You have the wheel, and in the bottom of the wheel is located the pump. And the pump have the reservoir integrated. The reservoir is located here. You can add the fluid here at the reservoir. That's the reservoir, and this is the wheel. Right? This is the pump. It's a mechanical pump. It's a mechanical hydraulic pump. It's mechanical because you activate the pump with your hand. When you move the wheel, the pump is activated. The hydraulic pump or helm pump is a mechanical pump. The wheel is located here. Produce the mechanical movement. When the mechanical movement is produced, the rotation activates those servo valves or body valves located here. And here in this area is located the compartment. For that reason, you have the cap to fill the hydraulic liquid here. You fill the liquid, and right now the reservoir is full of liquid, and the body of valves is ready to receive the fluid when the wheel is moving in one direction or other direction. This port is connected with the starboard side, line, and the other port is connected with the port side line. The port side and the starboard side is connected here and here. The bottom one in the middle, this one, is the return. The return is used to return the excess of fluid into the container on the reservoir. And right now we are going to talk about the reservoir. This is the helm pump. The helm pump is divided into the reservoir for the liquid, and the body of valves here where the servo valves are located. One valve to control the flow in one direction, and other valve to control the flow in other direction, port side and starboard side. When the wheel is moving in this direction, the fluid is going out here and return over there. When the wheel is moving in the opposite direction, the fluid goes out here and return over there. It's too simple. And the return collect the excess of fluid into the reservoir. If I have a simple boat, like the boat that I have on the screen right now, in this boat, if you check, I only have the helm pump and I have the cylinder in the back, but I don't have, in the middle, I don't have reservoir. What is the advantage of the reservoir? This is the reservoir. That's the reservoir that is located on the screen right now. The reservoir is important for three important reasons. In the reservoir, I have the marks to indicate the level of the fluid, and also to indicate the color of the fluid. This is critical. The color of the fluid and the level is critical. Normally, the fluid should be located in the middle of the second window, the top window. In the middle of that window, the fluid should be located. And the rest in this area, in this compartment, should be full of air. Air, yeah, because the air pressurizes the system. For that reason, in this container, in this cylinder, you have a valve here, like the valve that you have in your bicycle, in order to introduce air with the hand pump. And normally this system works with 35 psi, in between 30 and 35 psi. This is the pressure, the operational pressure of this typical power steering system, 35 psi. Okay, this is the reservoir. The level of the reservoir should be here. Those windows are important in order to verify that the fluid is in the appropriate level, and also that the color of the fluid is the normal color of the fluid. Normally in those hydraulic power steering system, the color is like a yellow, it's clear yellow. or red, because some people prefer use automatic transmission fluid, red color. This is a good choice. The automatic transmission fluid have a good quality, good detergent. Those detergents not affect the cylinders, not affect the O-rings of the systems. Or if you wanted to use it, the hydraulic fluid recommended by the manufacturer is like a yellow color, is good. No, that's your decision. And also, I recommend always follow the manufacturer recommendation. If the manufacturer of your hydraulic system recommend that specific oil, use that oil. That's the most important part. Follow the manufacturer recommendations always. Okay, the cylinder is good for to check the level of the fluid in order to verify that I don't have leaks. What happens if suddenly the level of the fluid is here? I have a leak. No, I don't have leaks. You have a leak. You have a leak. Normally, if you have a leak, what is the symptom? Suppose that you check in the boat and you no leaks, but the level is down. It's because you have a leak. You need to verify carefully and you find where is the leak. When you have a leak of fluid, normally the steering wheel is moving soft in one direction and hard in the other direction. Not hard in the other direction. Or is moving with intermittent movement in one direction and soft in the other one. This is because you have a leak and you have air on the line. This is a typical consequence. We're going to check later that. Alright, the reservoir is good to check the level, to check the color, and it's good to keep pressurize the system because you introduce air with pressure over there in that area and you pressurize the system. What is normally the pressure operation for those systems? In between 30 and 35 psi. This is the operational pressure. Of course, once again, depend on the manufacturer. Hey, Mr. Lopez, I have a system that operates with 40 psi. Okay, this is the recommendation of that specific manufacturer. Follow that specification and keep that gauge in 40 psi. Okay, follow the manufacturer recommendation. This is the function of the reservoir, and it is very important. If I have a boat like this, like the boat that you have on the screen, can I install a reservoir over there? Yes, you can. It's simple. And finally, if you install the reservoir, the situation is like this. You need cut the port and starboard lines, and you need insert in series the reservoir. If you check this picture, we have the port side. This is the port side. This is the starboard side. And you cut the lines and you insert in series the reservoir, and you continue with the port side and starboard side line connected into the cylinder. It's too simple. Once again, let me show to you in this particular example. Those are the lines, port side and starboard side, coming from the bottom from the hand pump. The port side and starboard side are cut. I install the fittings. I connect in one side of the reservoir tank, and from the other side I continue into the cylinder. I interrupt the lines and I insert my reservoir, and I connect the return connected into the return of this equipment that we are going to talk later. Alright, if I don't have this equipment, I connect the return of this into the return of the hand pump. When I have this equipment, if I have that equipment, I have two options. I can install a T here with one line for this return and other line for the return of the power assisted unit. This is an option. Or you can return directly here. But the recommendation is install a T over there, one line to return here and other line to return over there. Alright? Okay, this is the procedure to insert the reservoir. The most important part when you install a reservoir is prepare, fabricate the fittings appropriate for those hydraulic systems. Those fittings are special fittings. Those fittings are the fittings recommended by the manufacturer of this hydraulic reservoir. Those fittings are available in a hydraulic storage. I love hydraulic supply. There are millions of hydraulic storage, and they supply the appropriate fittings for those reservoirs. Okay, this is the function of the reservoir. 3 functions: keep the pressure in the system stable, because you pressurize to the valve with the hand pump, and keep the level of the fluid appropriate, and check if the color of the fluid is clean. If the color of the fluid changes suddenly, is for 2 reasons. Normally it's because water entered in the system. This is one of the reasons. And other reason is because the pump is damaged, the O-rings are deteriorated, or the pump, the cylinder, the servo cylinder is damaged, and the O-rings are deteriorated and degraded. Probably because the fluid that you added on the pump is not the appropriate fluid, and the fluid degrades the O-rings and the material of the gaskets. And for that reason, the color of the fluid right now is different. This is important. Once again, in other videos I mentioned, be familiarized with the odor of the fluids. Be familiarized with the odor of the coolant, the odor of the electrolyte of batteries, the odor of the motor oil, the odor of transmission oil, the odor of hydraulic oil. It's completely different. It's a special odor. This is important that immediately you open the door, the hatch of your engine room, only with the odor you identify if you have a leak. Oh, smell like a coolant. I have a leak of coolant in any of the engines or generators. It smell like hydraulic. I have a leak probably in a power steering system, or in the central hydraulic unit of my boat. It smell like a battery acid. Oh, probably I have a group of batteries with one battery in short, and the battery is boiling, and the electrolyte is evaporated, overcharging, and smell like acid. Yeah. Oh, I smell like a motor oil. I have a leak in one of the engines, one of the generators. I have the odor of transmission oil. You need to be familiarized with the different fluids in your boat. This fluid in particular have a special odor. Is easy to identify. All right, this is the function of the reservoir, and yes, it's very important. Install a reservoir. It's simple. You cut the lines, starboard and port, and you insert in serious quiz question. You insert in serious the reservoir on the system. Or if I have an autopilot system, is necessary to install the reservoir? Yes, it's mandatory, because the level of the fluid, the quality of the fluid is a very important factor in the installation of an autopilot system. This is another example of an outboard system. This is the helm. The reservoir, you check the return line connected with the helm, and the cylinder in the back. Those are different type of boats with a reservoir located in between. The reservoir is critical. I recommend always install a reservoir. All right. In this particular example, this is a boat with a dual station. One station, one helm on the flybridge, and other helm on the pilot helm. Both helms are connected. Let me explain quickly what is the procedure to connect this. Look at this hand pump. In this hand pump, I have one port for port side line, other port for starboard side line, and I have in the bottom one port for the return, in order to connect the return with the reservoir tank, and this one is other port to install a T and connect the upper unit or lower unit. You can install other hand unit on the flybridge, and you use that port to go up into that connection. And the connection is like this. It's exactly like this. You see, you install this over there, and you connect this helm in parallel. In parallel with the top one. That's okay. All right. I have I want to introduce this picture. This picture is nice because it's the typical this is the typical power steering system in a typical boat with two inboard engines with two rudders, two inboard engines, and two helms, one on the flybridge, other on the pilot helm. And this is the reservoir of the fluid. They added one filter for the oil. This is good idea. And they added other important element is the heat exchanger. That's the heat exchanger in order to keep the fluid of the hydraulic system properly refrigerated, properly cooled. Yes, we are going to check in other of our episodes, in the episodes related with the heat exchangers in diesel and gasoline books. I recommend visit my webpage and check on the diesel book or gasoline book the episodes related with the heat exchangers. And yes, in a typical, suppose we are going to talk about the diesel engine, typical diesel engine for a medium boat. We are going to check how many heat exchangers I have in a typical diesel engine. Try to think in the diesel engine, and we are going to refresh the concept, and we are going to think how many heat exchangers I have in a typical diesel engine. Yes, I have one heat exchanger for the coolant, correct. One for the coolant, other one, for the motor oil, yeah, the oil cooler for the engine oil, perfect. And other one for the transmission oil, 3, perfect. Other one, coolant, motor oil, transmission oil, yes, for the fuel. Remember, the diesel, 80% of the diesel coming from the fuel tank return into the tank, return with high temperature. For that reason, when the fluid return into the engine, return with high temperature. For that reason, you need to install a heat exchanger in order to cool the fuel, in order to avoid vapor lock. We are going to study later in the class of diesel that situation. Yes, number 4 is for fuel. Other one, heat exchanger for coolant, heat exchanger for motor oil, hydraulic oil, heat exchanger for fuel, and other heat exchanger for the air, the intercooler. You remember in diesel engines, in order to avoid vapor lock, you need to avoid that the air enter in the combustion chamber with excessive temperature. Remember, the operational temperature in the combustion chamber when the engine is running in normal conditions is around 1075 degrees Fahrenheit. If the air coming from the turbo is coming with high temperature, enter in the combustion chamber and pass the limit of 1000 degrees Fahrenheit and produce vapor, and the vapor produce vapor lock and destroy the valves and everything, blah blah blah, right? Yes, normally in a typical boat you have 5 heat exchangers, and other heat exchanger, the last one, the number 6, is dedicated for the power steering system. The power steering system of the boat, the liquid, the hydraulic fluid is refrigerated with the heat exchanger number 6. This is the heat exchanger number 6. That heat exchanger could be connected to the starboard engine or to the port engine in order to keep the oil of the power steering system as low as possible. Alright, this is the typical installation of the power steering system. And let me show to you this one. This is the actuator. This is the cylinder. The steering cylinder. That one, exactly like this. And the other one is a servo cylinder. This is a servo cylinder. In this particular case, it's a hydraulic servo cylinder. This servo cylinder is like this, my friends. This servo cylinder is like this. This one is not hydraulic. This one is electric servo cylinder. In this particular case, in this electric servo cylinder, the signal is coming from the computer of the autopilot. When the computer receives the signal from the GPS, the computer calculates how much is necessary, adjust the rudder, and this element is connected with the arm of the rudder, like the screen, like the picture that you have on the screen right now. This actuator, electro servo cylinder, is connected with the arm of the rudder and steer the boat in the direction that you want. Okay, this is electro servo cylinder, and the servo cylinder that you have in the picture in this particular case is a hydraulic, like the servo cylinder that you have on the screen right now. Yes, we are going to integrate all of those equipment in the autopilot system. And one other element that we are going to introduce additionally is the hydraulic pump or power assisted unit that right now we are going to talk about that unit. I am going to explain something. You remember in your car, if your car is off, what happens when you try to move the wheel? It's hard, no? Yeah, you can move it, but it's too hard. What happened immediately you turn on the engine? What happened with the steering? Oh, it's completely soft. Yes or not? In your car, if you try to move the wheel right now, you can, but it's too hard. When you start the engine, immediately the engine is running, the steering system is soft, and you can move the wheel in both directions easily. This is possible in your car because in your car, you remember that pump? The hydraulic pump? This hydraulic pump, that pulley is connected by the bell with the crankshaft of your engine. And this pump interrupt one of those lines, cut it, one of those lines, and this pump is located in series. This pump is located in series. I interrupt any line, I cut the line here, and I insert my pump in series. And right now, my pump is connected with the bell on the crankshaft of the engine. Immediately I start the engine, my pump starts, and my system receives extra pressure on the system. And right now the system is completely soft in both directions. This is the pump that you have in your car. This is the power assisted unit in your car. This is the power assisted unit in your car. This is a mechanical power assisted unit. It's mechanical because it's moved by the pulley with the bell connected with the crankshaft, and immediately the crankshaft is spinning, the pump produces high pressure. This is the reservoir. You added the oil here, you remember? You added the oil here, and the body of valves is located in front of this. This is similar to this one. This is similar to this one. Hydraulic mechanic pump. Very similar. And this is the reservoir where the oil is located. Yeah, when the pump is spinning, you send hydraulic fluid with high pressure in the system. Yes, my friend. If you don't have power assisted unit like this, the pressure of the system is 35 psi. When you introduce the power assisted unit, the pressure increases until 60, 70 psi, depending on the manufacturer. Yes, you produce extra power on the fluid, and of course, right now, the movement of the fluid is at high speed, with high pressure, more pressure, and right now, the system is operated easily. This is the situation that you have in your car. For that reason, when you turn on the engine, the power steering system is soft. When you turn off the engine, the power steering system is too hard. That's okay? Right? And this is the system, and this is the mechanical power assisted unit. Okay, in your boat, you can install pumps like this on the engine, but the hand is located far from the engine. In your boat, the hand is located. Look at this. This is the helm. This is the helm, and this is the engine. Look at the separation. It's 20 feet, 25 feet, 50 feet, depending on the boat. It's too much distance. For that reason, the recommendation is install other power assisted unit, not mechanical, electrical, like this. This is the power assisted unit, mechanical, 12 volts or 24 volts, depending of the boat. Yeah, there are boats configured in 24 volts. The power assisted unit is 24 volts. There are boats configured in 12 volts. The power assisted unit is configured in 12 volts, depending of the boat and depending of the battery bank. Okay, the power assisted unit introduce extra power on the system, and right now the movement of the wheel is pretty soft in both directions. Alright, I can install my power assisted unit without autopilot? Yes. I want in my boat, like the boat that I have in the picture, the boat that I have in the computer right now. This is the helm, and this is the engine outboard in this particular case, but you can install with inboard, exactly the same. And I am going to introduce my power assisted unit, and the procedure is exactly the same like with the reservoir. You cut the port line, you cut the starboard line, and you introduce the power assisted unit in series with the port line and starboard side. The dot line located in between this one in the middle is the return line. Okay, I can install here the power assisted unit, and here in this area the reservoir. Both of them should be located in series. You cut it port and starboard lines, and you insert the power assisted unit in series. Don't forget, quiz question. In series. Alright, this is the procedure. It's very, very simple. We are going to refresh. I have the port side and starboard side lines. I cut the lines. I insert my reservoir. I continue with the lines, port side and starboard side. I cut it again, and right now I insert my power assisted unit. And after that, I continue with the port side into the cylinder and starboard side into the cylinder. And right now my system is ready. My system right now have a reservoir and an electrical power assisted unit. Okay, that power assisted unit can be installed isolated like this, and I install a power switch like this, or need to activate the pump. When I start my engine, I activate my pump, or you can install that unit connected to the ignition switch in the position ignition. What is the color of that cable? Yes, purple color. And you install in the ignition switch, immediately the engine is running, that power assisted unit start, and the system is soft. When you turn off the ignition switch, the power assisted unit is turned off, and no more power. In this side of the power assisted unit, we have the port side, the starboard side line connected directly into the cylinder. This is the regular hydraulic cylinder, and this end of the cylinder is connected with the rudder arm. This end is connected with the rudder arm. Port side, starboard side, and this is the return, connected with the return on the reservoir. If you check, there are two ports on top of the port side and starboard side. Those are the bleed ports. In order to bleed the air, you move the wheel in both directions and you bleed the air. Those are the bleeders points. Those are the bleeders points to bleed the air with the appropriated range. The bleed points, port side, starboard side, and this is the return. And the unit is 12 volts or 24 volts, and the unit can be connected isolated with a switch on off, or connected to the ignition switch in the ignition position, purple color. And now we are going to analyze the procedure to bleed the system, the procedure to eliminate bubbles in the system. Yes, this is the enemy of the hydraulic systems, are the bubbles on the system. Remember that in a typical hydraulic system, we can add the fluid in two positions. One is on the helm pump, on the hand pump, remember that we have the feeding, we can add the fluid over there, and we added the fluid in this way. It's simple. With a funnel, we added the fluid. Or we can add the fluid on the reservoir. Remember that the reservoir have the cap on top. We can remove the cap and we can add the fluid over there. This is the first step, is added the fluid at the level, and after that we need a pressurized system. You remember I explained the procedure to pressurize the system. And after that we are going to move the wheel in both directions, and on the cylinder, on the rudder, we are going to bleed the system in this way. One of the most common problems with hydraulic systems is air entrapped in the fluid. When the fluid is foaming, when the bubbles pass through the pump, the diameter of the bubbles increase, and those bubbles block the system. This is common in different types of hydraulic systems. If you remember in previous episode in the fuel injection pumps, the enemy of the fuel injection pumps, of course, the water and the air. This is a typical hydraulic system, and the air is one of the enemies. What is the symptom in a typical steering system like this? When the air have too much bubbles, probably when you move the wheel in one direction is soft, but probably in the other direction is hard. This is the symptom when the fluid have too much bubbles. Now we are going to bleed the system. When you bleed the system, you eliminate those bubbles, and now the system is soft in both directions. What is the procedure to bleed the system? You need to prepare the wrench appropriate for the bleeder. The wrench appropriate. You need to prepare fluid, because you need to recover the fluid on the console, on the hand pump. You remove the cap, and you added more fluid, and you put in back the cap. You need to tie the cap properly. You can bleed the system in two different ways. You can bleed the system here at the cylinder. You can eliminate the air here on the bleeders, and also you can bleed the system here on the cap of the reservoir. You open the cap a little and you close again. What is the idea? You move the wheel in both directions, right side and left side. When you finish the movement in one side, you release the port of that side, and you see the fluid coming out with bubbles. You tight again the fitting, you move the wheel in both directions, and once again repeat the procedure in this direction, and you bleed again. If the fluid is coming out with no bubbles, the process finished. You need to repeat that process in both directions. We are going to do the process right now in clockwise. Can you move the wheel clockwise, please? Move it, move it, move it, move it, move it, move it. Okay, and now we are going to release the pressure here. Okay, no bubbles here in this direction. Can you move the wheel in the other direction, please? Okay, and now we are going to bleed the system here. The fluid is coming with no bubbles. We are going to repeat. Right side, please. Quickly, 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 quickly. Okay, and now we bleed again. Okay, no bubbles. Can you repeat in the other direction? Quickly, 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 quickly. Okay, no bubbles. In this moment, the system is properly bleeded. No air on the system. This is the procedure. Okay, my friends, and now we are going to analyze the power steering systems used in the E-Tech Evinrude. You remember in our course of gasoline, we work a lot on that boat with the Evinrude engines. Yes, we are going to check how is that system that is electronic and hydraulic. It's a system that have integrated the steering systems with the trim systems. Of course, that system is controlled by the computer, and the adjustment special. If the adjustment is out, probably you have a code on the screen indicating that the system is improperly calibrated. It's a system where the steering systems and the trims are integrated in one unit. We are going to visit the marina of Mr. Rodriguez, and we are going to speak with Danny Rodriguez, and we are going to talk with Mr. Glenn about that system used in the E-Tech engines. Danny, an Evinrude 300 horsepower.
G2, correct.
How is the power steering system here?
Well, if you look at the picture above,
yeah,
that's the steering that you see when
it's
the motor's off.
No?
It's integrated. This is all integrated, so the power steering pump is on the motor instead of being in
that pump.
Right. And then these are the hoses that goes from the helm, from that picture of the helm,
the typical
goes directly here. And so how this works is there's sensors on the motor, on the pump itself.
Yeah.
So when it knows it's getting pressure, it knows it has to turn that way. It's all computer controlled.
It's here.
It's all inside there.
Oh, nice. No, because you don't see the ram external.
No, there's no rams.
Yeah.
See, the Verado has the rams on the outside.
Yeah.
And everybody has the external C-Star, U-Flex rams. That's because it's outside. This is actually integrated in the engine.
Integrated. And it's electro-hydraulic, no?
It's electric hydraulic, correct. It's actually it's hydraulically with electric assistance.
Correct. And when you have codes on the computer, those codes are related?
Yeah. Like for instance, if you have a bad pressure sensor, it'll give you a 214 code. Now, that's not a code for the engine because
no, exactly.
Now you can read the engine codes, and on the control box has a brain that you can read the brain on the control box, and that brain on the control box detects the code for the steering system.
The rest of typical troubleshooting for hydraulic system, you have the bleeder over there.
Yeah, here's your bleeder, here's your hose. So when we do a bleeding on this, we actually use a power probe.
Oh, okay.
And basically what that is, it's just like an electric pump. And what we do is we hook up, and you hook up to the helm, and you hook up two hoses back here, which we'll do a video on that, explaining that. Because I think the best thing is to explain both methods: the old school method, and then the hydraulic.
I explained the old school.
Okay, now I'll explain you. So when you hook up the system, you hook it up and you open it so fluid starts coming out.
Correct.
So when you have the key on, because you need the power steering, you turn the wheel and it'll push all the air, and it'll put the air into the power probe tank.
Yeah.
Okay?
Nice. Yeah.
Power purge tank. And so until there's no air. And then what you do is you have one person, and this is what I do. You don't have to, but I like it because I want to make sure I get it done in one shot. We'll push the motor to help it, to move it quickly, and then we'll vice versa.
Okay. In that way, you are 100% sure.
Absolutely. The old school method will take you 5 times the amount of time when I use a power purge.
Yeah, I remember.
Power purge is like, in 5 minutes we'll have this blip.
Great system, no?
Absolutely. This system is a great system.
The patent is Evinrude?
The patent's Evinrude. Evinrude's the only one that has this.
Okay, all right. Because in the other one, I see the rams, the external rams.
Yeah, the rams. The Verado has the ram mounted up in the front, and the C-Star is mounted up in the front as well.
Correct.
So, the Verado one is integrated in the motor, but only because it's bolted on.
Oh, yeah, but no, this is not integrated.
It's not integrated 100%.
Yeah, correct.